Okay, Unit 7.3, rectangles. Our central question, how many properties do you know about rectangles? Well, a rectangle is a parallelogram. So a rectangle is going to have all same 5 properties as a parallelogram. Opposite sides are still congruent. Opposite sides are still parallel. Opposite angles are still congruent. Consecutive angles are supplementary, and diagonals are still bisecting each other. So all that is true. However, rectangles are a little more specific than parallelograms, so they have a few more specific properties that are just for them. And so one of them that we already know about rectangles is all 4 angles are right angles. Right? So if we draw this rectangle off to the side, which I should see on your paper too, we know all 4 angles are right angles. So most of you already knew that about rectangles. So the new property here is that diagonals are congruent. Okay, so not only do diagonals bisect each other, diagonals are also congruent. So let's take that and go to the picture. If we have this diagonal, which goes from corner to corner, and this diagonal, which goes from corner to corner. So remember that diagonals bisect each other. So we knew that, and we know this. Okay, but in a rectangle, both of those diagonals are the same. So we actually end up with all 4 of these half diagonals being congruent. So that is a property that is unique to rectangles. Okay, so in our directions, it tells us that each quadrilateral is a rectangle. So I know how many properties about rectangles? Count above. I know 7 properties about rectangles. So when looking at a problem, I'm going to have to figure out which property is going to help me with that problem. So let's look at number 1. So it's still a parallelogram, so I know opposite sides are congruent. So that helps me find that QR is 10. And SR is 24. Okay, SQ. Now this is actually going to bring up something that you guys have seen before in previous math, but we haven't talked about this year. And so this triangle uses one of our new properties. Remember, all angles are right angles. So I actually end up with a right triangle. And if you guys remember, there's a formula that I can use on right triangles that'll help me find a missing side. So remember that that side across from the right angle box is called the hypotenuse. And we have this property called the Pythagorean theorem that says a squared plus b squared is going to equal c squared. But I like to remember that it always equals hypotenuse squared. So here this is going to equal, well, we don't know. That's the variable that we're trying to find. So we can just say x squared. And we know the other 2 sides are 10, so square it, and 24, so square it. And let me remind you how to solve this. 10 squared is 100, and 24 times 24 is 576. Combining our like terms on the left-hand side, we get 676. So that's the value of x squared, but we only want to know what x is. And so there's this button on your calculator, and it's on your smartphones too. We need to take the square root of x squared in order to find out what x is. So when we take the square root of 676, we get 26. So that means that hypotenuse, that SQ, is 26. Okay, so then what's PR? Well, PR is the other diagonal, and remember, diagonals are congruent. So if SQ is 26, PR is also 26. And then what is QT? Well, remember, all 4 of these inside segments on a rectangle only are congruent. So if the whole line's 26, we need to break it in half. So QT would be 13. Okay, and I'm going to give you what x should be over here when you do that Pythagorean theorem, because I want you to practice that. You should get 13.1. If not, you're not setting that one up correctly, and so let me know in class and I'll help you with that. And there is answers for you to try number 2. All right, looking at number 3, notice this one's only talking about angles. So the only angle labeled in the picture is 27 degrees. Remember, I can still flip it around. This is still a parallelogram. So everything we've done so far, we can keep doing. Let's see what it wants me to find. MJK. So it wants me to find this angle right here. Well, remember, this is a rectangle. So I know there are 4 right angle boxes. MJK is the whole angle, 90 degrees. But now they want us to find MJL, so that's where I'm putting this dot right here. Well, if the whole thing is 90 and this piece is 27, to find MJL, we need to do 90 minus 27. So this is 63, which we know if we flip around, this is 63. All right, JLK. JLK. Hey, that's right here where we just wrote the other 63, alternate interior angles. Okay, KML, we are also trying to find, and let's look at something that happens here in rectangles also. So because this is congruent to this, so MN and NL are congruent, notice that this triangle right here is an isosceles triangle. And because that's an isosceles triangle, remember that the angles across from the tick marks are congruent. So you actually end up in a rectangle with 2 angles that are going to be the same in each of those little tiny triangles. So KML is 27 degrees. MNL, well, now we need to find this top part of the highlighted triangle. We know 2 out of 3 angles of a triangle, so 180 minus 27 minus 27 will tell me what that third angle of the triangle is, 126 degrees. And let's look at number 5. Number 5 tells me that DB is 42. Remember that this is a parallelogram, so diagonals bisect each other. If DB is 42, I don't have a way of writing that in the picture, but I can half it and write that each piece is 21. Okay, let's also remember that each of these pieces are going to be 21 because in a rectangle, all 4 of those little inside lines are the same. All right, AD is 26. And the measure of angle DAE, this right here is 52. So let's see what it wants me to find. AC, 21 and 21, that's 42. EB, we have that written as 21. BC, notice we have a lot of this already because we filled in information as we go, or as we went. All right, so they want me to find AB, which is here. And without knowing what CD is, that opposite side, we're a little stuck at how to find that. So if we put an X there, let's recognize that if I go ahead and close out that triangle right there, then I can use Pythagorean theorem because it's a right triangle. So the hypotenuse is this side across from the right angle, which is 42. So this is going to equal 42 squared. And the other 2 sides are the 26 and the x. So x squared plus 26 squared. All right, so let's use our calculator here. These are big numbers. 26 times 26. And 42 times 42. And we're going to solve this like we would any other equation. We're going to subtract the 676 and get x squared equals 1088. So if I square root that, I get a decimal. Remember, we're looking for this sign in the calculator. I'm going to get the x is about 33. So the length of AB is about 33. Which again, if I needed to know, remember I could go down here and write 33 also, because opposite sides are congruent. All right, so now they're asking us about angles. Put my degree signs there, ADC. ADC. That's this right here. It's a right angle because this is a rectangle. ABD. Now, don't get excited. We have 21 there, but that's not an angle. Remember, that is the segment, a part of the diagonal. Okay, so follow me on ABD. I'm going to put a little purple dot right there. That's the angle that we're trying to find. Well, remember that all of these inside pieces are the same, so you end up with an isosceles triangle. So I know that this piece is 52. And also remember that every corner is a 90-degree angle. So to find the purple dot, I need to do 90 minus 52. And I get that this is 38 degrees. BCA I have listed as 52 degrees because we used our alternate interior angles. And DEC, I'm trying to find right here where I'm circling. Okay, so if we use the same logic on C down here, we know C is a 90-degree angle. One of the pieces is 52, so 52 plus what gives me 90? 90 minus 52, I get that this is 38. Remember, it's an isosceles triangle, so this is 38. So in order to find E, I have 3 angles of a triangle, and now I'm going to be talking about this green triangle right here. I know 2 out of 3 angles, so I'm going to do 180 minus 38 minus 38. And I get 104. Okay, so using your properties to navigate through these problems. Let's look at number 6. Number 6 says find the length of EF. Okay, right there. So all I need to do is find X and then plug it in right there to EF. Well, this is a parallelogram. Remember that opposite sides are congruent. So this problem shouldn't feel new, being that it's a rectangle. It's the same properties as a parallelogram. So when you solve that, you get X is 11, plug it into EF, and you see that EF is 38. Okay, remember to pause so you can get the information that you need and work out the problems. Eight, if JM is X plus 17, right there, and MK is 5X minus 23. All right, so they're giving me these highlighted pieces, that part of a diagonal and that part of a diagonal. Well, remember that in a rectangle, all 4 of these diagonal pieces are congruent. So these are equal to each other. Pause and solve for X. And then it wants us to plug into JL. Okay, well notice we don't have information for JL. JL is the entire diagonal. But I know that JL is twice of JM. So if I plug into JM, I see that it's 27. So all of those little pieces are 27 and 27. 2 27s together tell me that JL is 54. All right, we'll do 10 next. 10 says find the measure of angle BCE, which is this angle right here. Okay, we'll realize that we have alternate interior angles labeled. So this piece of angle A that I just colored blue and this piece of angle C that I just colored blue are alternate interior angles and they're both labeled. We know that alternate interior angles are congruent. So set these equal to each other. Pause and solve for X. I got X equals 2. So let's see what our strategy is now. We know that all of C is 90. If we plug into this part of C, then we can do 90 minus that angle to find angle BCE. So let's plug into there. 11 times 2, we get 19. So this angle is 19 degrees. So if we do 90 minus 19, we get 71 degrees.